Question 3. Well, part A is just like question 2 before, so if we want to rationalise one of these, how do we get rid of having a square root on the bottom? If it's a single term, we just choose to multiply top and bottom by the same single term. So we're going to multiply top and bottom by root 2. 6 times root 2 is 6 lots of root 2. Root 2 times root 2 is the square root of 4, which is 2. So we have 6 root 2 over 2, 6 divided by 2 is 3, so that's 3 lots of root 2. Now for part B, I'm trying to include in this test as many sort of problem solving type questions as normal. So if you get a question like this and it says find the area of the triangle, don't get phased by the fact we've got surds in it. Just think, how do I work out an area of a triangle? Well, it's half times base times height. So just follow through your normal maths and just see what happens. So half times this times this. So multiply out the numerators. 1 times 6 times 6 is 36. 2 times root 2 times root 2. Well, root 2 times root 2 is root 4. So 2 lots of root 4. Square root of 4 is 2. So 2 2's are 4 on the denominator. 36 divided by 4 is 9. Question 4. Well, part A is just another one like the previous one, so we choose to multiply top and bottom by root 7 over root 7, giving us a final answer of root 7 over 7. This is rationalised. We're allowed to have square roots on the top, just not allowed to have them on the bottom. Now part B, key thing, when you've got something squared like this, don't forget what this means. This just means the bracket times itself. So root 3 add root 15 times root 3 add root 15. So do your usual claw, gather up your so do your usual claw, which I've done here. Now look that we're aiming to end up with some root 5, so that will help you with the simplifying. Square root of 45 is the same thing as the square root of 9 times the square root of 5. Remember what we're trying to do? We're trying to find two numbers that multiply to make 45, one of which is a square number, in other words 9. So root 45 is root 9 times root 5, repeated here. So from here to here, well, the square root of 9 is 3, so this is 3 lots of root 5, as is this. So we've got 3 plus 3 root 5 plus 3 root 5 plus 15. Gather your normal numbers, gather the root 5s, we get 18 plus 6 root 5. Now for part 2, again, what are we being asked to do? All measurements are in centimetres. Find the value of k. So we've got 3 sides of a right-angled triangle. Again, don't get phased by the right-angled triangle by the fact we've got surds here. What do we know about sides in a right-angled triangle? Well, from Pythagoras, we know the square of the two shorter sides, these two, equals the square of the hypotenuse. So you need to see through the question, realise it's Pythagoras, and kick off by saying this squared plus this squared equals this squared. So this is the problem solving line. This gets us into the question. Once we're this far, it's not too bad. So k squared, that's fine. 3 plus root 5 all squared. Remember, that's 3 plus root 5 times 3 plus root 5. I've done that over here, and it simplifies to 14 plus 6 root 5. That's this term here. Now our right hand side, it's very helpful if you spot this is exactly what you've just done in part B1, otherwise you just repeat yourself. So this all squared is 18 plus 6 root 5. Now you can see that we've got 6 root 5 on both sides, so we basically take that away from both sides, so that cancels, leaving us with k squared plus 14 equals 18. Take away 14 from both sides, k squared equals 4, so k equals 2. A tricky question.